Hey guys, I hope everyone's doing well. This is for my Tuesday, Thursday class, February the 11th, and my Monday, Wednesday class, Monday the 15th. It should be our shortest, simplest lesson yet. I certainly hope so. All right, so just some quick vocabulary review. A constant in math is a value that doesn't change. Also a whole number, usually a whole number that is not attached to a variable. Okay, it doesn't have to be a whole number, but we're going to start using a lot of variables, which of course is a letter that represents a number in math. A constant is a number that does not have a variable attached to it. Now the coefficient is the number that is being multiplied by the variable. Okay, so look at the example 3x plus 4. You find your variable. In this situation is x, and the number that's being multiplied by x is 3. So 3 is the coefficient. It says a coefficient is the number attached to the variable. Variables that have no numbers have a coefficient of 1. So if you have simply x minus 3, the coefficient of this x is 1 because 1 times x is x. So don't think you have a coefficient of 0. That's not true. It'd be 1. And then terms are separated by plus or minus signs. So since I see a plus symbol here, we have 2 terms here, 3x and positive 4. And then also the one that I wrote, there's a minus sign. So we have 2 terms again. So x is 1 term and minus 3 is another term. So the number, the term includes the symbol in front of it. If you don't have a symbol, obviously it's a positive term. All right, so let me get rid of my scribbles. So our constant here is 4 because it's not attached to a variable. Our coefficient in this situation is 3 and our variable is x. There are 2 terms, 3x and positive 4. All right, so the next vocabulary term is the word integer. So integers are all whole numbers. So when you started counting as a little kid, you counted 1, 2, 3, 4. All of those are whole numbers. Integers include their opposites. So the opposite of 1 is -1. The opposite of 5 is -5. The opposite of 20 is -20. And integers include the number 0, which of course is a placeholder. So these are a list of examples of integers. So we're moving on to 4R2. So this section only has 2 units, 4R2, or 2 sections, 4R2 and 4R3. So the first thing we're going to do is identify like terms. Like terms or similar terms are terms that are constants, which means they're whole numbers that aren't attached to a variable, or they're terms that contain the same variables, if any, raised to the same exponent. For example, 18 and -4 are like terms. They're both constants. They're not attached to a variable, so they're constants. Now look at these 2 variables, x squared and x squared. So the x squared makes these 2 terms like terms. So we have 5x squared and 3x squared. All right, the next 2 are like terms because both of them have the variables x, y squared, z. X, y squared, z. This one has a coefficient of 3, and this one has a coefficient of, who knows, -1, right? And then finally, ab to the third and ab to the third makes these 2 like terms. This one has a whole number as a coefficient. This one has a fraction, but they're still like terms because of the variables and the exponents match exactly. So let's look at this. Identify the terms in the following list of terms. Identify the like terms. So what are like terms? So here's a 6. So what is a like term with my 6? It's a constant. It's not attached to a variable. So that means that this is also a constant. It is not attached to a variable. Those are like terms. What else do you see with no variable? 0 has no variable, so those 3 are all like terms. All right, so here we have a variable of x raised to the first power. What else do we have x raised to the first power? This one, right? So the coefficient would be -1, x raised to the first power. This one is a like term. The coefficient is -5 times x to the first power. So those 3 are like terms. And then finally, we have x squared z, x squared z. So those variables and exponents make these 2 like terms. This one has a coefficient of 3, and this one has a coefficient of 3/4. So hopefully you guys identified those on your own. Let me get rid of my scribbles. All right, so hopefully we'll have the same answers. Absolutely good. Awesome. All right, now you try it. So pause my video. I want you guys to identify the like terms. All right, so we have constants. We have constants. Actually, that's my mom's name. Isn't that funny? All right, okay. All right, so we have a constant of 5/3, no variable, -1, no variable, and once again 0, no variable attached. Here we have an x to the first power, x to the first power, so these are like terms, and this one, x to the first power. This one has a coefficient of 10, this one's coefficient is -3, and this coefficient is -5.65. And then finally, we have x squared z and x squared z. So those are like terms. All right, so I think these come out of your college algebra book. I'm pretty sure they do. But let's see what we can figure out, true or false statements. Determine whether each statement is true or false. If a statement is false, explain how it can be changed so the statement will be true. Number 1, a variable that does not appear to have an exponent has an exponent of 1. Is that true or false? It's true. So if we say 5x, that exponent is to the first power. So that is true. In the term -9x, 9 is being subtracted by x. That's not true. That is false, right? So how would we make it true? 9 is being multiplied by x. So if you have a coefficient together with a variable, they're stuck together, that shows multiplication. In the term 12a, 12 is the constant. That is not true. A constant is not attached to a variable. So in this situation, 12 is the coefficient. And then the last one, like terms have the same coefficients. Once again, that's false. Like terms have the same variables. And I should say and powers. Powers is another word for exponents. All right, so you guys look again, identify the like terms in this list. So our like terms are our constants. So we have -5, 3, and 8. Those are all like terms. Also, we have 7x, 9x, and then the one that's all by itself would be 3y. That one's all by itself, isn't it? All right, so if we were in class, I would ask you guys to get with a partner, discuss like and unlike terms, and give an example of each. But we're virtual, so you can tell your pet, tell your dog, give your pet an example of like and unlike terms. All right, so these are the type of problems you will come across in Hawks. You'll be given an expression like this, and one of the questions will be, what is the first term? So the first term in this expression is 5y. The second question will be something like, Is this a variable term or a constant term? So we're going to say it's a variable term. You would click the box that says variable term. What is the coefficient? Well, the coefficient in this term is 5. What is the variable? It's y. And I think Hawks asked that in the opposite order. The first thing it'll ask is what's the variable, and then what's the coefficient. So read those carefully. What is the second term? Now the second term isn't just 6, it's actually -6. So you have to include the sign in front of it if it's a negative, okay? If it's a plus, you don't have to write +6. You would just know it's a +6. Is this second term a variable term or a constant term? Well, it's constant. It does not have a variable attached to it, and that's it. All right, here we have 3 terms. We have -3y, -x, and -6. So the first question is, what is the first term? So the answer would be -3y. Second question, is this a variable term or a constant term? So we would choose a variable term. Then it would ask us, what is the coefficient and what is the variable? The coefficient is not 3, it's -3. And of course, the variable is y. What is the second term? The second term is -x. Is it a variable term or a constant term? It's a variable term because I say a letter. Then it'll ask, what is the coefficient? So the coefficient of -x is -1. That's the coefficient. And if it asks what is the variable, of course, we would say x. The third term is -6. Is -6 a variable term or a constant term? And we would say it's a constant term. It is not attached to a variable. So that's basically that whole section, you guys. Isn't that easy? All right, so then we're going to try combining like terms. In other words, we're simplifying expressions. So when you have 2 like terms, you can add or subtract their coefficients. For example, if we have 2x plus 3x, since these are like terms, you can combine +2 and +3, and we would get +5x. All right, so on your paper, excuse me, your practice paper, you have these examples. So since these are like terms, you are simply going to combine 2 minus 3.5. So 2 minus 3.5 is -1.5y. All right, that's the answer. If you're not sure, put in your calculator. 2 minus 3.5 is -1.5. Now look at the second one. This says 8x plus x. Well, what's the coefficient? The coefficient is 1. So 8x plus 1x is 9x, right? All right, the third example, these are all like terms because they're all multiplied by a to the first power, a to the first power, a to the first power. Okay, so we're just simply going to use our calculators. I'm just going to put into my calculator with my fraction button 1/4 plus 2 minus 1/2. And I get 7/4. So this is equal to 7/4 a. And if I want to turn that to a mixed number, I would say 1 3/4 a. Either of those are equivalent. Okay. All right, on this slide. So anyway, I think there's like 5 more questions probably. I want you guys to pause the video and see if you can get these on your own. All right, so let's check our answers. So this is going to be 2 plus 4 is 6x. The other ones are unlike terms, so we simply add those to our answer. And there's nothing else we can do because these are unlike terms, so that is the final answer. All right, the bottom one, let's start with the highest exponent. So positive 6y squared minus 1y squared. 6 minus 1 is 5y squared. And then the other 2 terms are unlike each other. So we're going to write positive 7y plus 5. Now, if you wrote the 7y first, And then 5y squared plus 5 is totally fine. You don't have to have these in a particular order, okay? We're going to talk about writing them in standard form eventually, but right now that's totally fine. It doesn't matter as long as your coefficients are right and the sign in front of the coefficient. So in this case, these are all positive answers or all positive terms. All right, what about these three? Hopefully you guys did these. So 0.7a minus 0.6a is 0.1a, and then 4 plus 6 is plus 10. Like I said, if you wrote the 10 first, totally fine, doesn't matter. All right, now these two problems we haven't really discussed, but I think you all can do the distributive property. We're going to distribute 5 times 2x, so 5 times 2x is 10x, plus 5 times 3 is 15, plus 1x. Then we combine like terms. 10x plus 1x is 11x plus 15, and we're finished. All right, the bottom one, the very last problem, we're going to use the distributive property. We have 2b squared plus 4b plus 6 plus 1b squared plus 5b. We're going to combine like terms. We have 2b squared plus 1b squared, which is 3b squared. And then we have 4b plus 5b, which is 9b. And then our constant is plus 6. All right, how'd you guys do? Even though we can't add or subtract like terms, we can multiply like terms. So that's what we did there. All right, I think that's it, you guys. No kidding. This was like the shortest video ever, wasn't it? So hopefully you'll find that these two lessons are pretty simple. So that's good to start a unit off with some pretty easy lessons. Hopefully you noticed that those weren't too difficult. So that should increase your confidence. I hope it does. All right, you guys, so I will see you at during class, and let me know if I can help you before then. You guys have a great day.